start. Hello, good morning and good afternoon and good evening. Welcome you again to this World River and Delta System Source Sync webinar series. And today we invite Professor Paul Liu give us a talk about the Irrawaddy River Delta, particularly focused on alarming signals. What's the message of this delta telling us now, and what we could learn from other Asia deltas. Before I introduce Paul, and I would like to see this coming Friday, Professor Torbjörn Törnqvist from Tulane University. He will talk about the Mississippi River Delta, mainly talk about Mississippi River Delta and other world major deltas, particularly focus on the coastal marsh, the impact due to the sea level rise. So please mark your calendar and coming back this Friday. And so, okay, Paul Liu, I know Paul very well. Actually, I know him since he was born. And Paul graduated from Ocean University in China and got his master's degree in the Chinese Academy of Science in 95. In 97, he went to Virginia Institute of Marine Science, College of William Mary, studied with Professor John Milliman and got his PhD, then stayed short for a short postdoc, then spent 6 months at the Woods Hole Oceanography Institute, Hawaii, as a short postdoc before moved to NC State University as an assistant professor, now is a full professor at NC State. In the past 20 years, Paul has been actively studying or working on the East and South Asia major river system, particularly focused on the feeds of those rivers derive sediment to the sea. Specifically, he has conducted research of the following river and delta system. For example, his PhD research focused on the Yellow River derived sediment all the way from Bohai to the North Yellow Sea and the South Yellow Sea. And later on, he and his colleague also conduct a 506 cruise in the distal part, longshore sediment transport in the South Yellow Sea, and also off over the Yellow River Delta and the river mouths in the South Yellow Sea, this area. And one of the major his contribution and study is focused on the Yangtze River derived sediment in the East China Sea, a longshore transport all the way to the Taiwan Strait. And from 2004, 2005, 2006, he conducted more than 6 research cruises around the Taiwan, try to understand the Taiwan, the small mountains river derived sediment to the sea, and also look at the Pearl River sediment in the northern South Yellow China Sea. And then 2006 and 7, 14 and 15 conduct 6 cruises with David DeMaster, with Chuck, and in the Zuoxue, of the Mekong River Delta, and also 10 and 11 in the Gulf of Tonkin, understand the Red River derived sediment to the sea. And most recently, he and his colleague is working on the Andaman Sea, try to understand the Irrawaddy River derived sediment to the sea. So in the past, there's many colleagues like Dave DeMaster and the student Zuoxue in LSU now, Chuck Mitchell was still Kiel, John Milliman, Courtney Harris, Kevin Xu, Professor Yang in Ocean University, and Hou Jie Wang, and Anchen Li, Shu Gou, and in Taiwan, the Jia Xuan, and Vietnam colleague, and Professor Ang from Myanmar, and Yoshi Saito in Japan. Many colleagues work on the East and South Asia river derived sediment, but mainly focused on the feed part. And many of those kind of focus on the not only the feet, but the longshore sediment transport, for example, the Yangtze, not only the proximal depot center, but also the big longshore portion have a distal depot center, same thing as the Yellow River and the Mekong, you know, understand not only near the river mouths, the proximal sediment second stratigraphy, but a longshore sediment transport and the botted and the second stratigraphy. And for example, most recently, the Irrawaddy, you know, the work. So also some of the work is, you know, pretty good impact, and but still have a long way to go. And hopefully with this trend, you know, when I reach 60, you know, I can reach at least 15,000 citation. Maybe before I retire, I can reach 20,000. Try to catch up with you guys. But I don't think I can catch up John Millman. Millman already 33,000. And so, but anyway, so today I will focus on the Irrawaddy River Delta, you know, the alarming message from the Irrawaddy Delta. So the Irrawaddy, you see that the Myanmar here, this is the delta. Overall, like other low-lying delta, the elevation of this delta is only about maximum 5 to 6 meters. So because the low-lying area in 2008, 12 years ago, there is a tropical cyclone Nagis coming here, caused the storm surge 40 kilometers inland and caused at least 138,000 people died. Almost 140,000 people died. One event. This is not 100 years ago. This is only 12 years ago. In 2008, you know, one event, we caused 138,000 people died, and at least 2.5 million homeless. If you look at the data, you know, the tropical, this is category 4 and make a landfall almost, you know, then become category 3. That's still a huge. And as you can see, the storm surge is almost 2 meters to 5 meters, someplace reach to 60 meters. As we mentioned earlier, majority of this delta, the maximum elevation is 5 to 6 meters. So this is no surprising that so many places is inundated, is flooded. So as you can see this picture, many places was flooded, inundated. So as you can see that the destruction caused many people homeless over the delta. And as you can see here, you know, in eastern coast of United States, when hurricane coming here, so we are this is not new, but over there, this lowland area is devastating. Particularly, as you can see, this picture. I'm sorry I put this so disturbing picture, but when I saw this picture, you know, particularly those kids, my heart feel very heavy. I'm very disturbed. You know, this is some of the reason I will see if one of our work, if we can see one life, I think it's worthy our research. If we can, you know, help the people, we see one life, one kids. I think nothing is more important than a life. When we saw this, you know, we feel, you know, we have a long way to go. And also, when we talk about this river system, last year, there was a paper published in Nature. It said, mapping the world free flowing river system. Here stated very clearly in the abstract, only few very long rivers remain free flowing, such as the Irrawaddy and Shoreline River. So this river so far, compare other major water river, is kind of relatively undisturbed. I will say relatively, because based on the World Wildlife Foundation report, the Irrawaddy River system is almost the river basin covered 61% of the Myanmar total country area, and 66% of the people, living over the river basin. And also, this river facing many problems. For example, like a bank erosion, flooding, river morphology changes, pollution, navigation track problem, mining problems, sedimentation, biodiversity, fishing species degradation. But if you look at the delta here this is a very large fertile delta, support more than 6 million people over this delta, provide 60% of country's rice production. It's like the Mekong Delta, the Irrawaddy Delta also is the rice bowl for this country and also for the surrounding country, because they also export the rice out. But this delta, the delta itself, have lots of challenge. For example, the navigation, 23% of the navigation problem, 21% the river morphology change, and 18 and 20% bank erosion, and also water quality issues and flooding problem. So I will today, this kind of talk, as I mentioned to you, my research is mainly focused on sediment transport, after they deliver to the ocean, focus on the feed part. Today is kind of a little bit social environment geography, not really kind of my field work, but this is kind of like a storytelling. We will cover the following part. I will talk a little bit the delta, I'll talk about sediment discharge, talk about shoreline change, the delta subsidence, the sand mining, the mangrove forest, saltwater intrusion, flooding, the inundation problem, and also the storm surge and the future studies. So just to relax, we just give you a little bit the kind of the overall, what's the challenge, what's the alarming message from this delta system, and what we learn from other Asia large river systems. Tectonically, as you can see in the Pacific, we know very well this is the Ring of Fire. But in the Indian Ocean, the Bay of Bengal, we know this is the Indian plate, and the subduction into the Eurasia plate. We know that Sumatra, very famous, the Sumatra, the earthquake and the tsunami back to 2004. But we know the subduction, we have a back arc basin extended all the way to the north to the Andaman Sea. The whole Andaman Sea is a kind of result of that subduction as a back arc basin. There's a faulting, subredding fault, goes through all the way through the Andaman Sea into this delta near the river mouth, the Saguenay fault coming through here. And of course, not surprising because of this tectonic setting over here, this is the earthquake happened very often, all the way extended from Indonesia to the Andaman Sea, to the Myanmar, to the Bangladesh, as you can see here. And at the same time, the Irrawaddy and the Shoreline River dumped together collectively about 600 million tons of sediment into this backup basin. From all over the world, the major river system, if you think about the Amazon, if you think about the Mississippi River, if you think about the Yellow River, Yangtze River, the Nile River, the Indus River, the Mekong, and you name it, no any other river like this river dumped directly so much terrestrial fluvial sediment to this tectonic active back arc basin. Nowhere. So that's a very unique thing for us to focus on this river and the delta system. And as you can see here, the Irrawaddy River Delta basically is forming between those two mountain ranges. The mountain ranges here, and in the west, the Bay of Bengal, and also in the east, it's kind of forming here. Now it's kind of facing to the Andaman Sea. It's like the open ocean here. So if you look at a little bit more specifically, the Irrawaddy River Delta is more than 50,000 square kilometers. And in the west, this is the Indian Burma Range, the mountain range. In the east, this is the Bago Yuma mountain range. As you can see, this delta, the triangle shape of sediment accumulated in this area. In the past 6,000 to 7,000 years, this is basically from the middle Holocene, after sea level reached to the high stand, the delta prebadage is more than 250 kilometers. On average, every year, the delta prebadage is 30 to 40 meters. So that's actually pretty common if you look at other major world delta prebadation during the Holocene. It's about 30 meters per year. But if you look at a little bit more detail, our colleague review, have a couple borehole over this delta. The surface stratigraphy indicate, this is a 6,000 years timeline, 4,000 years, 1,000 years, the propagation. And this is also clearly show, about, 30 to 40 meters per year propagation. But let's look at the sediment. The sediment, because this river is in a tectonic active region, all the way from the Tibetan Plateau and flew down and between two mountain range. And the sediment based on Robinson, the data from 1960 to 1995 show roughly, as you can see here, is about accumulate about 300 million tons. And as you can see here, the red dash line is about around 300 million tons on average, and pretty stable. And most recently, a couple weeks ago, our colleague Yotis presented his recent study and his recent publication over the JGR show the field survey, during the winter, during the late spring, and in the summer, show the river discharge and also sediment flux. And his conclusion is Irrawaddy kind of deliver more than 300 million tons. And this is match the previous very well. The survey may be a little bit lower, but as you can see, that's a pretty good constraint, the number for us to get a pretty standard, pretty constant, the sediment load, sediment discharge through this river system. But if you look at this shoreline analysis, show in the past 150, 120 years, 100 years basically, the shoreline almost no change near the river mouth. But if the sediment still coming down 300 or 350, million tons per year, but why the shoreline is no propagation? If you look at the Holocene history, it's kind of at least 30 meters per year. So then we conduct some more detailed analysis in this area. So we also show near the river mouth in this area, actually even show a negative on average, put everything together near the river mouth, even show a negative. And why, the question is. So if you look at a little bit more detail here, near the Passon here, and so as you can see, this is the shoreline in 1974, this is 2008, as you can see the retreat of shoreline. And if you look at the sea in this year here, there is in 1974 and 2008. And then if you look continually, it's kind of show a little bit, some place is retreat, some place a little bit, again, a little bit is not even, not universal distributed pattern. And in the eastern part, particularly east side of the Yangon River, even you will show a pretty significant gain of the land from 1974 to 2018. And overall, our analysis show in the western part of the coast, near the river mouth, more than half of the shoreline is under strong erosion, severe erosion. In the eastern part, even in the eastern part, overall still is a gain, still progression pretty good. So this is the picture, this is the status. If we focus on this area, if we zoom in this area, we can look a little bit detailedly. Look, for example, here, and this is from 1984 to 2018, 16. And as you can see here, and in the roughly about almost 40 years, the progression almost 400 meters, the retreat almost 400 meters. On average, the shoreline of this specific area retreat 10 meters per year. And also, overall, this area, is kind of in the western part, is increase the erosion. And in the eastern part, it's increased accretion. This is the trend. So if we even look at it even further to the east in the Tectonic river mouth, so our Japanese colleague did some survey in this Tectonic estuary, showed the dynamic change of this tidal dominated estuary. And as you can see here, this is the tidal ball, coming here, just like the Amazon, like the Yangtze, the Chinatown, the Hangzhou Bay, you see the tidal ball coming. It's very significant. The tidal range here, sometimes up to 6 to 7 meters. So it's pretty significant. And there's a dramatic, also there's some dramatic change. But, our colleague from the WWF also indicate the sediment shifting because of the dominated wave and longshore drift is kind of eastward based on the shoreline grain size analysis. This is pretty coarse sand material, and more fine mud is shifting to the eastern toward to Yangguang and the Gulf of the Montalban. And as you can see, near the river mouth in the western portion of the delta, the sand is dominant. There's not too much fine mud material. Mud is relatively much less compared to sand dominant. But when we shift to the east side, you can see the sand is pretty dominated, and but the mud increased a lot on the nearshore area. And also we have some offshore data in the later on I will show you. So. And our colleague Edward Anthony, also show this trend, that kind of mud flux from the west to the east, based on the shoreline analysis. So let's focus on, let's look at this delta. As we mentioned, this Irrawaddy Delta in the western side, eastern side, both was framed. It's kind of constrained between this uplifted mountain area, but in this valley, form the extensive delta. The Yangguang city is here. So we studied some based on the INSA data, understand how about the displacement, the most recent 2 years displacement. As you can see, in the 2 years, someplace even up to 16 centimeters of the, that kind of subsiding, around this delta area. Some spots relatively have a little bit uplifting. So if we look at the real data, and near the Yangguang here, the subsiding is up to 4 centimeters per year. 4 centimeters per year. Compare the rise of sea level. Sea level is just is nothing. This that's caused the problem even much severe, because 4 centimeters per year, almost 10 times than the sea level rising. So, but anyway, it makes things much worse. So if you look at the building, as you can see, that's subsiding here, and you can see here, the change. So the groundwater usage is one of the big, beside the natural compaction, the groundwater usage is one of the big costs, believe. So as you can see, the drawing of the water, the use around the city, urban areas is very, very severe. So So that's something challenge. And when we put the low elevation together based on the Climate Central, their organization, their prediction, if the temperature rising at a scenario 4-degree warming, that's you can see in next 2100, you will see that's majority of this delta could be inundated because the sea level rise. If only rise 2 degrees, the temperature change, as you can see, almost more than half of that delta, maybe 60% also be inundated. And as you can see already today, if there's some storm here, as we show in the earlier, the cyclone Nagis is caused a huge damage. And also the prediction, to the 2100, the year 2100, those potential area that could be impacted, particularly with the subsiding of this area. And also, if you look at the global coastal nation and at the risk, and in Myanmar here, with a different scenario, with a 4-degree temperature change, a 2-degree temperature change, even 2 degrees warming, you will cause at least 10% of the country's population will be impacted. So this is the big thing, over particularly the population living over the low-lying delta area. And let's look at the mangrove. The mangrove, this is 1974. The green color indicates the mangrove forest. But let's focus on this specific area. You will see the dramatic change, 1974. And next is 2000. That's 26 years later, as you can see, that change. You can see here, the green, you can see how much, the mangrove we lost. And then 2017, 17 years later, as you can see further, you can see this area. See here? Now you see the change. So overall, across the whole delta, 80% of the mangrove had been lost. That's a big change. And before 1980, there's a roughly 700 square kilometers mangrove. After 2014, there's less than 100 square kilometers. Now, even less. So that's a dramatic change. If you look at this area, specifically this island, and as you can see, this is 1974, and this is now. You see the dramatic change, how the land cover changed, shifted. And most of this land change, the deforestation, the mangrove is becoming farmland, shrimp, ponds, or other, industry manufacture. And so as you can see, that's kind of big shifting over this delta. And other thing is the dams. Even the people in the beginning said relatively the Irrawaddy and the Shoreline still a free-flowing river system in the world, but there's so many planned in consider the planned. You see the reservoir and the dams over there. But we have already know there's a big consequence to build the dam over the river basin from other river system. We will talk about a little bit. So other thing is the sand mining, because we know you build a dam and the reservoir, you will definitely sharply decrease the sediment supply and the discharge to the delta and to the ocean. Other big threat is the sand mining. So this is the news report over Irrawaddy River at risk from the sand mining. And as you can see, the bank bank 20% of the challenge is the bank erosion of the river. And so as you can see here, the data, the official report from the World Wildlife Fund report 2016 estimate about 20 million tons sediment, about 10% of the total sediment flow through the river was mined. And it's coarse material, as you can see here. But the data all based on the report from other 113 standard mining business in the Yangon alone, the city alone, this city alone is 8.5 million tons per year. So plus those unreported, illegal, unofficial number. So the sand mining, the removal of the sediment from this river could be double, even triple of this report number. So for example, as you can see here, that's the situation, people so crazy try to take advantage of the river sand as money, and they can use the very good material to use and good revenue actually. And if you look at here, so the big truck and small canoe, not only the big dredging boat, but how can you estimate, how can you calculate how much of the sediment removed from the river? Use those kind of, small countless, the small boat. That's the kind of a challenge. And so we need to understand how much sand is available for us. We cannot blame them. They need to survive. They need to want to make their life better. But how we can manage this, how we can guide this, how much of sand we can move relatively safe to the river system, that's kind of the thing we might help them to answer this. And also, our recent work also show this is the river you see, as you see, come here all the way as Passon here, used to be a very major distributary coming to in the west, a major estuary. But now this become smaller and smaller, shallower and shallower. More than 90% of the river actually shifted to the east, to the Irrawaddy, and also go to the Yangon, 30% coming down here, and only, other 30% coming to the middle. But we also show the satellite image also show there's more and more river in the river channel. The sandy shore, is built up in this, developed in this area. It's kind of become abundant river channel. So there's kind of less and less sediment really, deliver to the western portion. And why? So this could also help us explain why the western coast, the shoreline is even more severe erosion compared to the eastern portion. But not only the sediment, there's also some tectonic background behind that. I will mention a little bit later. So this is the river morphology change. You see that our colleague also working very hard. They try to understand the sand mining impact, over there. That's very important for us to understand the same thing here. This is on the Mekong Delta, but we need the kind of survey over the Irrawaddy River channel. So to understand how much the impact of the sand mining and how the river morphology channel responds to this removing. And so how about the future of Irrawaddy? Of course, when we talk about the future, we need to make a lesson from other river system, because something already happened over the Mekong, over the Yangtze, over the, the Ganges-Brahmaputra. So what we try to do is, in Myanmar, our colleague, we do not need to repeat. We do not need to make the same mistake. There's some lessons we can learn from other delta systems. For example, like Yangtze. Yangtze, we know because the dam, because the human impact, the sediment sharply decreased from 500 million tons to now is kind of 100 million tons. Because of this, if you look at the the offshore area, our colleague from East China Normal, they show clearly, that kind of a big erosion already happened over the inner shelf, in the shorefish Subsidence Delta area. And as you can see the compare the more positive accumulation was the negative erosion. And the Mekong is show a similar story. So because this is the Mekong, the dam built over the Mekong, and also something coming in construction. So the Mekong used to also propagate 30 meters per year, similar as the Irrawaddy River Delta. But if you look at the shoreline, the red color show this is the erosion. And over this area. Near the river mouth, there's some portion still accretion. But if you look at a little bit more detailedly, our analysis show after 2005, 15 years ago, the delta, actually the area from positive gain shifted to a negative gain. So this is a more kind of a paradigm shifting, in 15 years ago of the Mekong. If we look at a little bit more detail, we show a similarly trend. You see near the river mouth, the propagation, but away from this SMB from 97 to 2015, this is the retreat, and this is the erosion. So this is very clear already. Like you see the strong erosion here, 1950, 65, 2015. It's every year, this is about 20 meters, the retreat. As we already show over the Irrawaddy, some portion already show 10 meters per year, the retreat, the erosion. So the Irrawaddy kind of is following the step of the Mekong. That's alarming message. Mekong is already in this source to source talk series, a couple talk already given, talk about how dangerous, is somehow, we try to avoid use the word hopeless, but there's still some hope, but still the situation is very desperate because of this kind of thing happening over there. So we do not want the Irrawaddy repeat what happened over the Mekong. So for example, the Mekong used to be delivered 100 million tons, but now it's only 22 million tons delivered to the Delta. That's alarming message. So the Irrawaddy, if continually the sediment decreasing, or the sand mining of the Mekong is up to 40 to 50 million tons. If Irrawaddy, the sand mining is no control, continually remove the sand, the shoreline area, the delta could be facing the similar fate, similar problem, and also similar like the subsidence. Like our colleague Philip Manderhood just gave a talk a couple weeks ago. Over the Mekong, there's also up to a couple centimeters per year, similar to what we observed over the Irrawaddy. So we see the other with the Irrawaddy situation is similar to what already happened or is happening over the Mekong. For example, we use the INSA show, there's could be up to 10 centimeters per year, even in some area, of the Mekong. That's very, 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 very bad the situation. 4 to 5 on average. The nearby, like Trophy River, is a similar thing. As you can see, 1960s, there's a huge sediment, but now it's of no sediment. And so the problem, because the sea level rising, because the subsidence, the Bangkok, we know is very, 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 also with big challenge, it's very bad. Some even eastern part of the Bangkok, or even elevation even below the sea level now. And you can see here, the compass, the road, and you see this area. So, and also the shoreline, 1950, 1970, 91, 2009, you see the retreat of the shorelines. So every year in the Gulf of Thailand, the coastal line retreat about 5 meters per year. And so, as you can see here, also flooding. So now back to the Myanmar. So the Irrawaddy now, the climate is driving, also the human impact is also combined, like the saltwater intrusion over the paddy field. And so if you look at based on this report, the Delta Alliance, GWP, the reported vulnerability, and resilience, you can see the salinity change. So as you can see, the intrusion of the with the tidal change, with the seasonally, the salinity almost, the saline water almost intrude most of the delta area. That's caused a big challenge for the life of the people who live in this area. So, and of course, we can see build the dam will reduce sediment load, and also sand mining, and of course, further reduce sediment load. And then, you have a bank will cause the bank and the coastal erosion, because the, sand mining reduce the sediment load, and also you cut down the mangrove. You cut down the mangrove, and you deforestation, you turn to the mangrove forest to a farmland. It's a kind of, for the local people, this is a kind of, it's a smart way to do, because they get more land. The land is valuable, but they didn't realize the forest is also valuable too. And so when you cut down more forest, remove the mangrove to a shrimp pond, to a farmland, then you cause the more strong erosion problem. And so you further cause the riverbank and the coastal erosion. Then combined together, you have more the kind of saltwater intrusion. You kind of remove the sand, so you cause the tide or moving more inland. So this is kind of combined everything together. So this is what happened. Also the subsiding, the subsidence. So that's the situation, and withdraw the groundwater. This is the situation over there. And as you can see, there's more studies show, deforestation will cause a big problem over the river, like what happened in Amazon, what happened over the Mekong, and as you can see here, as you can see the illegal sand mining, in this area. So also, as you can see, the climate is kind of in a tipping point, and so there's a many challenge, like because the climate, the Greenland ice sheet lost, the forest, the Amazon, the circulation, the Antarctic, and the coral reef, permafrost, and so, but the delta, the sinking delta, is another big alarming signal, and particularly in this lowland dense population area. And for example, the Irrawaddy is the least one of the big, one of the delta in Pearl is kind of a dangerous condition. And so the last thing I want to say, the tectonic also contribute, make the situation a little bit worse compare other passive margin delta system like a Mekong or Yangtze. So in here, as we mentioned in the beginning, this is in a back arc basin area and also subduction offshore, because the subduction offshore, you cause the uplifting in the fore arc area, because the trench here is uplifting this side in the west, and at the same time, like a tear down, the subsiding in the back arc basin area, also a spreading, there's a spreading tectonic basin. This is also further cause the subsiding. That's the kind of a combination reason for Yangon, the big city over the delta, is facing the subsiding. And also possible the uplifting may be caused the river channel more shallower and shallower, and less water and the sediment coming down the western portion. So over the 5 million years, the uplifted 5,000 meters, roughly about 1 meter per 1,000 years, this area. And so many, even the coral reef in the western portion, because of the tectonic, because of the earthquake, is kind of become subaerial. That's another big challenge, as you can see here. And so, overall, this is a diagram help us understand the tectonic impact. So because the subduction about 4 centimeters per year, coming from the Indian plate to the Eurasia plate. So this is near the beginning of the Holocene, 6,000–7,000 years, the middle Holocene. So the real mass is here. And with progradation, the delta progradation to the sea at about 30 meters per year, the progradation rate. And then, this portion, because the subduction in the western part was uplifted, was pumped up at the rate of 1 meter per 1,000 years. And in the Andaman Sea area, the depression subsiding also similar 1 meter per 1,000 years. Overall, then we're going on, 2,000 years ago, this portion continue rise up. And in the Gulf of Martaban and the Andaman Sea continue is sinking. So now it's kind of uplifted this portion, depressed in the eastern side, in the Gulf. So that's the diagram. That shows the tectonic impact. So overall, we have 7 to 10 meters was uplifted, and this is similarly. So there's about 50 meters difference displacement. Because of this, we think this might explain long-term, gradually this portion kind of stopped growing because also the open ocean and it's shifting to the east side. But of course, the wave, the longshore current are the driving force, but tectonic also contribute. So an example we can say is the Ganges-Brahmaputra, as you can see here. The Ganges-Brahmaputra, if you show just like the Mississippi River, the lobe is shifting around, but this one originally from middle Holocene in the western part, close to India, but gradually shifting to 5,000 years, 4,000 years, and 200 years, gradually shifting to the east. I think the Irrawaddy will also following this step and is also shifting to the eastern side. Like our colleague Steve Keel come out to this cartoon, as you can see, this is the stable shoreline, actually is a retreat, not too much modern sediment coming down really to the west and is shifting more and more to the east. And now offshore, the mud mainly accumulated in the Gulf. But if you even look at, it's kind of shifting to the eastern side. Gradually, the Gulf of Martaban will be filled. And it's just like the Ganges-Brahmaputra, it's shifting gradually to the eastern side. And so this also, our seismic also show the thickness of the mud over the northern part of the Andaman Sea in the Gulf of Martaban. As I mentioned, this is my research. The thing I talk about today is just like a story, it's just something fun to share with this community. As you can see, this part with the high accumulation rate up to 10 centimeters per year, gradually, I don't know, maybe I haven't calculated yet, maybe 500 years, 1,000 years, gradually this part will be filled. And maybe then we can shift the same material now, not too much really coming to the canyon. Then after that, maybe there's more stuff will go through the canyon to the deep sea. So I think I will stop here. There's a couple of things I want to mention. We need to working together to understand how much of the water and the sediment the river discharge. We need a long-term observation, particularly see if any trend show the decline with more and more dam build up. That data is very valuable. Like a Yangtze, like the Yellow, the Chinese colleague did a fantastic job keep a long-time history record. The Mekong is a little bit pity. We don't have a pretty good long-term observation in the downstream. In the middle stream is okay, but the downstream not really have a pretty good station, a consistent long-term record. But we need to build up this for the Irrawaddy. I mean, that's the urgent need. And second, we need to understand how much sediment deposit over the delta, how much they deliver to the coast and the sea. And at the same time, we need to know if we have to take away some sand, we cannot blame the people there try to take advantage of the river. Of course, you know, they living by the river. If they can turn the sand to money, I mean, well, that's good. But we need to know the safe line. How much we can take the sand away from the river, relatively still ecosystemally, environmentally, hydrodynamically safe. And how does the riverbed respond to this dredging or to the removing, to the sediment reduction? This haven't been done, and we need to do this. This talk was originally given last December in Yangon to the government official and the local geoscientists, couple hundred people. So I kind of a devil advocate. I try to, you know, say very loudly, we need to build this gauge station. We need to understand the river channel morphology change and how much groundwater we can use or withdraw, you know, how this will relate it to the current subsidence. We cannot really control the tectonic, but we at least can control how we can withdraw the groundwater. And what's the impact of the mangrove deforestation? How about the fertilizer? How much of nitrogen phosphate being used? And how remove the mangrove will impact the carbon. Of course, the local people, they don't care about the carbon DOC, DIC, they don't care. But they should care about the eutrophication, the hypoxia, because what happened offshore the Mississippi River of the Yangtze River could happen over there, because over there we know that's a very important fishery ground over the northern Andaman Sea. They don't want to kill their the fisheries. I think we need to see clearly the message, and how about affect the coastal water quality, and how fast is the coastal eroding and creation. You know, what's the projection for the future? Because some portion you cannot stop the shoreline be eroded. Some portion you still adding the land. So how we can dance with the nature accordingly, harmoniously. That's the thing. At least as a scientist, we can to do. You know, and also the storm surge monitoring and the prediction. I think this is another very important thing we need to do with our physical oceanographer colleague. And so I think I will stop here. And if I turn on you can unmute yourself if you have questions we can discuss. And as I said, that's not a regular research presentation, more social, environmental kind of, you know, like a story to tell. Okay, I'll stop here. So, yeah, go ahead.
Paul, do you have any idea what the sand flux is? Like when Meade talked about the Mississippi sand flux, he had a pretty good idea of what the sand discharge was near the river mouth. Do you have a good idea what it is in the Irrawaddy, such that you get an idea of the fraction that's being removed of the total discharge?
I don't know, but definitely our colleague Eutas from University of Cambridge, UK, they did some survey across the channel a couple of times, but I can't remember exactly their number come out. I still assume roughly about 10%, but that's I don't know. The challenge is if you move the sand, as you can see, the legal or illegal, move the coarse material. When the river coming here, they will first to fill in that sandy pit hole. They will fill in that area, will sharply impact the stuff delivered to the shoreline. And of course, if we move the sand, the shoreline, the mud, very fine mud, can very hard to build the shoreline, because the strong wave, open ocean. And this is combined, maybe the shoreline cannot accurate that, no more. This may be the reason, but we need more research.
Hey Paul, thanks very much.
Hey.
It's a really interesting talk, actually. It's a really interesting background on Irrawaddy and lots of issues. Well, I was wondering, is there also any problem in the groundwater with arsenic in the Irrawaddy Delta? And has that been studied at all? Is that an issue as it is in other deltas across Southeast Asia?
You mean the groundwater withdrawal?
Yeah, no, in terms of arsenic pollution, is there any issue of arsenic in the groundwater in the Irrawaddy?
We all know that like the Ganges is arsenic is a big problem, but over there also some problem. But I don't know I know I read some report and it's some local study, but not too much, not many international publication about that. And I know the water quality is also some challenges over there, but overall the Myanmar, the research, particularly in the international platform, is just started, obviously.
Okay.
But definitely, what I try to do today is many things the Myanmar government scientists, they can avoid. Because some bad things already happened over the Ganges, over the Mekong, over the Yangtze. So something they can try, some lessons they can learn. Otherwise, it could be too late.
Jim, Lex Van Geen did start to do some work on arsenic in the Irrawaddy Delta, but then I think it was just too difficult logistically for permissions and things so that he stopped. But there is definitely arsenic in the Delta.
Okay, definitely. Okay, thanks, Mike.
Yeah, I don't know the extent of it compared to Ganges Brahmaputra.
Okay.
Because WWF, they are also actively working there. Actually, then our Dutch colleague, the Delft, and they have a couple report is available online about the some kind of mainly the water resources. Yeah.
Yep. Okay. Thanks, Paul.
Anybody else? Yeah. And if not, as I mentioned, this coming Friday, Tourbillon, we talk about the impact of sea level to the coastal marsh and Mississippi River Delta particularly. Hopefully all those talk, can help those, particularly the developing country area and also the major river delta area. And because of the political or the kind of reason, is not too much study conducted, but hopefully some lessons can land, and we can working very hard try to avoid the same kind of mistake is happen to other area, and so I think it could be important. But anyway, and if anybody need the PowerPoint is a 500 meg and is a big file, I maybe try to put a share folder and just let me know. And so if not, we can stop here, and I see you Friday. And also next Wednesday, we have one more talk before the Christmas. Okay, let me stop here. So thank you very much. Okay.
Many thanks, Paul.
Sure.
Thanks, Paul.
Okay.
Great talk.
Sure. See you.
See you later.
See you.
Nice one.
Thank you. Oh, that.
Yeah.
Oh, still, you mentioned about the Congo River, right? Are you?
No,
You? Oh.
that's.
Which river? Which river?
Oh, that should be the Niger.
Niger. Oh, yeah. Niger. Yes.
Yeah.
The Niger River, the Delta, also have a lots of the eroded problems, similar things.
Yeah. That's true. That's true. Your talk is actually very interesting.
Very good. You mentioned that you try to be a Fulbright visitor because the I'm happy to host you, but now the pandemic, now we cannot
Oh,
do anything.
yeah. Let's see what happens after the pandemic.
Yes,
Yeah.
I'm happy. And
Yes.
also, we can initiate the Niger River study.
Yeah, that'll be very interesting.
Yeah, as you
That'll
can
be
see,
very
we
interesting.
covered pretty much all the East Asia, South Asia. Gradually,
Yeah.
we want to shift all the way to maybe some African river system.
Yeah.
Niger is
Yeah.
definitely interesting to take a look.
Yeah, that's true. That's true. So thanks for the presentation.
Yeah, are you in your lab or at home?
Yes, I'm in the lab. Yes.
Okay. Look, the internet is pretty good. You attended the
Oh,
talk.
yeah, but presently I'm in France.
Okay. Oh,
Yes.
very good. So, hey, Edgardo, hello. I saw you here.
Okay, thank you.
Yeah. So, very good.
Yeah, thank
Yes, yeah.